Welcome to VSF Technology. I am Vivek Chauhan. Today we are going to learn insertion sort. Insertion sort is a simple sorting algorithm that works similar to the way you sort playing card in your hand. The array is virtually split into sorted and an unsorted part. Values from the unsorted part are picked and placed at the correct position in the sorted part. Algorithm of insertion sort. The simple steps of achieving the insertion sort are listed as follows. Step 1. If the element is the first element, assume that it is already sorted and return 1. Step 2. Pick the next element and store it separately in a key. Now compare the key with the all element in the sorted array. If the element in the sort array is smaller than the current element, then move the next element. Else shift greater than elements in the array toward the right. Step 5. Insert the value. Repeat until the array is sorted. Time complexity. In best case, the insertion sort algorithm has a best case time complexity of big O n for the already sorted array because here only the outer loop is running n time and the inner loop is kept still. Average case time complexity. The average case time complexity for insertion sort algorithm is big O n square, which increase when existing elements are in jumped order, that is neither in ascending order nor in the descending order. Worst case complexity. The worst case time complexity is also big O n square, which occurs when we sort the ascending order of an array into the descending order. In this algorithm, every individual element is compared with the rest of the element, due which n-1 comparison are made for every nth element. So, worst case complexity is also big O n square. Let's try to understand with the help of example. Suppose we need to sort the following array. First element in the array is assumed to be sorted. Take the second element and store the separately in key. Compare key with the first element. If the first element is greater than key, then key is placed in the front of the first element. Step first. Assume index 0 is the minimum element and second element is key. Then compare the element, and if first element is greater than the key, then key is placed the front of the first element. So first element is greater than the key, so swap the element and placed 5. Key is 0 index and 9 is index 1. Now the first two elements are sorted. Take the third element and compare it with the elements on the left of the placed it just behind the element smaller than it. If there is no element smaller than it, then place at the beginning of the array. Step 2. Assume index 1 element is minimum and next element 1 is as a key. Then compare the element and 9 is greater than the 1, so swap the element and 9 is stored in index 2. Next, compare the index 1 and index 0. Now 5 is greater than the key value 1. So again swap and store the 5 value in index 1 and store the key value at the index 0. Similarly, place every unsorted element at the correct position. Step 3. Index 0 and 1 subarray are sorted. Now assume the index 2 element 9 is minimum and next element is key. So compare the index 2 and index 3. Now 9 is greater than the key value, so swap the position of 9. Now 9 position is index 3. Now compare the index 1 value to key value and 5 is greater than the 4. Now swap the value of 5 with index 2. Now 5 is stored in index 2 and index key value are stored in index 4. Step 4. Now 0, 1 and index 2 are sorted and 3 and 4 are unsorted. So assume the index 3 is minimum value and next element is key. So compare the index 3 and index 4. Now 9 is greater than the key value, so store the index 4 and now compare the index 2 with the key value and now also 5 is greater than the key value, so swap the elements and store the 5 in index 3 and now compare the key element with the index 1 element and now 4 is the greater than the key value and now also the swap the value and store the 4 in index 2 and now store the key value in index 3. Now the array is sorted. Thank you.